we are going to explore the amazing world of coding with the fun project that involves pictures and computer learning and making the computers able how to learn them and recognize them. Let's start by importing some of the magical tools that help us to create and train our own picture detective. By importing TensorFlow SDF, this is a magical tool that helps us to do cool things with the great number. From TensorFlow.keras, we import some of the datasets, layers, and models. You can think this as of a special assistant to make our job most easier. After that, we should have some of the fantastic artists who will help us to draw these pictures. So this is Matplot here. Import matplotlib. Now imagine we have a tier of great number of pictures known as a Cypher10 datasets, and it's like having 60,000 pictures of different things, and our mission is to teach the computer to recognize them. Let's take a peek at the pictures. Imagine you have a photo album and you are flipping through the pages to see the first 25 images. A picture of an airplane, a picture of car, a picture of bird, etc. These are the just few of the pictures in our magical album. Now let's teach our computer friend how to understand these images. We have a convolutional neural network superhero looks at the parts of these pictures and figures out what's it in them. Now let's create our own convolutional neural network. As at this point we have a model that is models from sequential. This is like a building our own superhero team. After that, our superhero's first power is recognizing the basic shapes. So we are adding a layer of convolutional 2D layer with the 32 filters and 3x3 kernel size with an activation function ReLU and an input shape of 32x32 with the 3 color channels. After that, we have a special move like zooming into see the details. So for this purpose we perform max pooling 2D. So max pooling performs selecting the maximum number from particular window by convolving a kernel of size 2x2. After that, another power, we are making our model more powerful in order to understand the most complex patterns as well. So for that we are adding another convolutional 2D layer. Again, zooming for even more details. It's gonna be interesting to have zoom these images and look into for more details. After the zooming these pictures, we have again a powerful move with the finding and intricate details. This is like teaching our superhero to see different layers in pictures. Let's see what our superhero has learned so far. So we can learn this from the model summary. Our superhero's power are now organized as a chart with some of the important details. But wait, our superhero needs a brain to make the sense of all this information. So let's add a brain with the dense layers. Flattening out the information for easy thinking, like we are making our model to be in 1 dimension from the 3 dimensions. After that we are adding a dense layer. It's a smart brain move, understanding a big picture. After that, as we have the 10 number of classes, so the final brain move is making decision about these 10 different things. So now again let's see the superheroes complete chart with the brain included. This can be obtained using this model.summary function again. Amazing, right? Our hero is now ready to learn and make the smart decisions. This can be predicted from this can be depicted from this chart completely. Let's see our superheroes complete chart with the brain included. We have seen this, and now we are going to uh, train and compile the model. But how we do teach our superheroes, uh, it's a big question. Like, we can use a special language called compile and train the program. So model.compile is a function. It's like giving our superhero energy. We have used optimizer. It optimizes our model, means gives the energy to our superhero. After that, we are defining a loss function. This helps our superhero to learn from the mistake. Obviously, it's good to learn from your mistakes. Another term here is a matrix, that is accuracy, a way to measure how good our superhero is getting. Means along with this, we are monitoring our model as well. Now, our superhero will train for 10 lessons using our magical pictures. So these 10 is the number of epochs that will be used on our training images. From this training segment, you can see that our model our superhero has learned different things at each and every mistake, or at each and every lesson. Our superhero is getting smarter with each lesson. It's improving. So finally, when our model is compiled and trained, now we would evaluate the performance of our model on the test set. Let's see how well our superhero has learned by looking at a graph. So we are plotting the graph. Plot history and dot history accuracy and label it as accuracy. This is our superhero's accuracy over particular time. After that, we have a plot history dot history a validation accuracy with the validation accuracy. This shows how well our superhero does with the new pictures. Means obviously we have to test our data set on the new data set, new images, new pictures. plt.x label per epoch, this is superhero's learning lesson. That was at each lesson, at each epoch it was learning new lesson, or it was improving. plt.y label is an accuracy. This is how accurate our superhero is. After that, plt y limitation 0.5 to 1. This graph scales for superhero accuracy, means a particular scale that ranges from 1 to accuracy level. plt.legend, location lower right, this is a legend to tell us what's etc. what's at a particular number. And finally, let's see how our superhero does on big test with the pictures as it has never seen. That is the model.evaluate on test images with the test labels. So finally, we have a test accuracy of 71%. Boom, our model has learned with a good accuracy from the number of images. Now it is able to recognize images, and it can be correct up to 71%. So that's it for today. Hope you all have learned from this well. If you still have some of the ambiguities or queries, do let me know in the comment section. Looking forward to see you again in the next section. Thank you.